This is Mr. Martin. These are the video notes for Geometry Honors section 5.6. In this section we're going to be looking at the methods for proving a quadrilateral as a parallelogram. In one of the previous sections we looked at the definition of a parallelogram, and then we talked about the many properties that a parallelogram has. So based on the definition, we know that if a quadrilateral is a parallelogram, then the opposite sides, both pair of opposite sides, are parallel. And once we knew it was a parallelogram, we also found out that the opposite sides were congruent, the opposite angles are congruent, and there were several other properties. So in this section we want to figure out, well, what do I need to know in order to prove that a four-sided figure is in fact a parallelogram? So we're going to look at these 5 methods here. And your challenge when you're trying to prove a parallelogram is to figure out which one of these 5 methods you can use. Okay, so the first one is if both pair of opposite sides of a quadrilateral are parallel, then the quadrilateral is a parallelogram. So this is basically the converse of the definition. So if I've got my figure here, A, B, C, D, and if we know or can prove that AB is parallel to CD and BC is parallel to AD. So notice I have both pair of opposite sides, parallel, then we can conclude that ABCD is a parallelogram. Okay, so somehow in your proof you're going to have to figure out how to get both pair of opposite sides parallel. You may be looking, there may be a transversal drawn in somewhere. You may be looking at alternate interior angles, or some other way that we get segments parallel. So that's our first method. Second method, if both pair of opposite sides of a quadrilateral are congruent, again notice it says both pair, and in this case they're going to be congruent, then the quadrilateral is a parallelogram. So again, if I have my quadrilateral, and we'll call it A, B, C, D. I'm going to shorten this a little bit. So if AB is congruent to DC, and we need both, BC is congruent to AD, then we can prove ABCD is a parallelogram. Alright, so second method. First method, both pair of opposite sides parallel, then you can prove it's a parallelogram. Second method, both pair of opposite sides congruent. Alright, third one's a little bit different, and this is one of the more popular methods. So again, I'm going to start with my generic parallelogram here. So I've got again A, B, C, D. So for this it says one pair of opposite sides of a quadrilateral are both parallel and congruent. So we only need one pair of opposite sides in this case, but we need to get that pair of opposite sides parallel and congruent. So I'm going to look at just the left and the right side, but it could work for the top and the bottom as well. So if AB is congruent to CD and same pair of sides, AB is parallel to CD, then we can prove ABCD is a parallelogram. Okay, so notice I have the same pair of sides here, congruent and parallel in your proof. It doesn't matter the order that you prove each of those things, as long as you have both of them in your proof, then you can prove it's a parallelogram. Okay, so again, I'm going to stress it's the same pair of sides, congruent and parallel, not one side congruent and the other side parallel. That doesn't work. Okay, number 4, if the diagonals of a quadrilateral bisect each other, then it is a parallelogram. So we may use this once in a while. It's just not one of the favored methods just because it takes a little bit more time. So I've got A, B, C, D, more time and more steps. And we need diagonals in here. So here's one diagonal. Here's the other diagonal. And if AC bisects BD and, okay, so we need each diagonal to bisect the other one. BD bisects AC, then we can prove ABCD is a parallelogram. Okay, so again, you need to get each diagonal bisecting the other. Alright, and number 5, again, we'll use this once in a while, but not as often as the first 3 methods. So we've got our generic parallelogram, A, B, C, and D. This says if both pair of opposite angles of a quadrilateral are congruent, again, both pair, then it is a parallelogram. So if angle A is congruent to angle C and angle B is congruent to angle D, then we can prove that ABCD is a parallelogram. Alright, so make sure you're familiar with all 5 of these methods, because again, when you look at a problem, you're going to have to decide which of these methods is going to be best suited for that problem. So we're going to skip all the way to the end of the notes here to the section 5.6 example, and you can see here that I've got AF congruent to CE, and I've got that BF is parallel to DE, and I've also got that it's congruent to DE, and we want to prove that this big quadrilateral is a parallelogram. So what I'm going to see is if I can get both pair of opposite sides parallel, or both pair of opposite sides congruent, or one pair of opposite sides parallel and congruent. So since I've got these two segments are parallel, I can see that angle 1 over here and angle 2 over here are actually alternate exterior angles, and if I can get those congruent, then I can get these two skinny triangles on the outside congruent, and then I can get AB and CD congruent, so that will at least give me one pair of opposite sides congruent. So let's start there. So I've got AF is congruent to CE, and I've got BF parallel to DE, and I've also got that BF is congruent to DE. These are all given. Given, given, and given. Alright, and then again, since BF and DE are parallel and we've got AC as a transversal, I know that angle 1 is congruent to angle 2. Parallel lines implies alternate exterior angles congruent. And then from there, I can get triangle AFB congruent to triangle CED by side angle side from steps 1, 3, and 4. And then from there, I can get AB congruent to CD by CPCTC. And I can also see that these angles over here, where'd we go? I've got angle 3 over there, and I've got angle 4 over there. Those are also corresponding parts, and I can see that those are alternate interior angles. So if I can get those congruent, then I can get AB and CD parallel as well. So I've got angle 3 is congruent to angle 4 also by CPCTC. Since those are alternate interior angles and they're congruent, I know that AB is parallel to CD. So alternate interior angles congruent implies parallel lines. And now I see that in step 6 I have one pair of sides congruent. I have the same pair of sides parallel. So now I can say that ABCD is a parallelogram because if one pair of opposite sides of a quadrilateral are parallel and congruent, then it is a parallelogram. Okay? So again, sometimes you may not know what method you're going to use. Just start making some conclusions based on the information that's given to you. So we have quite a bit of information that's given to us. Just start making some conclusions, and hopefully eventually you'll figure out what method you need to use to prove the figures of parallelogram. So as always, if you have any questions, make sure that you write those down and ask me next time you see me in class. There's a lot of information in this chapter, so make sure you're keeping up. Make sure you're adding everything to your theorem sheets, and we'll see you next time.